This is our final demo to wrap up chapter 15. We have a bunch of imports at the top, the usual stuff that you're used to seeing here. Whoops, but we've got a new line here. We're going to create a new ball pane of class ball pane, which is a special class that has been written for this demo that we'll look at in just a moment. And then down at the bottom we have these other usual things that we do. And remember that when we want to have an object that's responsive to a key press, we need to request focus, and we have to do that after showing the stage. So we show the stage here, and then we request focus on our ball pane. Now, what this demo is going to do is it's going to have an animated ball that every time it hits the corner of or at the side of the stage, it's going to bounce off in an appropriate angle and continue around, continuing to bounce back and forth and all over the place within the stage. We're going to be able to exercise a couple of different controls over it. Mouse pressed is going to pause the demo. Mouse released is going to let the demo continue playing. And then we're also going to capture key events. So the up arrow is going to speed up the animation, and the down arrow is going to slow it down. So let's take a look at how we set up those things to happen. Well, first of all, on our ball pane, we do a set on mouse pressed, and we provide a handler which simply calls our ball pane with the pause method. So that's going to pause the animation. And we'll look at ball pane in just a moment to see how it's defined so we understand how that's going to work. When we release the mouse, we make our ball pane responsive to that event, and we provide an event handler here, again using lambda notation to do it. And we say ball pane dot play, so we execute or invoke the play method to get the animation to continue. So that's all that's going to happen there. Now down here, how do we speed it up and slow it down? Well, again, we associate with our ball pane a set on key pressed and provide a handler for that event. And the handler takes, because we know that when the event occurs, this object E, we can query it with the appropriate method, the get code method, to find out what key was pressed. And if the key code is the code for the up key, then we know the up key was pressed, and in that case we're going to call ball pane dot increase speed to increase the speed of the animation. Else, if the code was instead the down key, then we're going to decrease the speed. If there's any other key on the keyboard that was pressed, then we're just going to ignore it. So it'll only be responsive to the up key and the down key. So I guess that's fairly straightforward. There's not a lot going on there because all the work actually happens in the ball pane class. So let's have a look at the ball pane class then to see what happens in there. Well, the first thing I guess is that we have a bunch of imports that are important, and then we're going to extend the regular pane with our new ball pane. Here we specify a radius for what will be the circle that represents the ball that's going to be animated, and we have the x and y coordinates for its initial position also set to equal the radius. So in other words, it's initially going to appear at location 2020, and its radius is also going to be 20. So it's going to be in the top left corner of the stage when we start. We have here values borrowed from calculus, dx and dy, or delta x, delta y. In other words, change in x, change in y, which reflect the fact that these values are going to increase by 1 as we move from frame to frame. That will always move the ball sort of in the right direction and down, but when it hits the and has to bounce off one of the edges of the stage, then of course one of these values is going to turn around and become negative instead. And we'll see how that works when we get to that point in the code here. We create a circle. We give it location x, y, and radius, as I mentioned earlier. We're going to create a timeline called animation. And then here is our constructor for ball pane. So we take our circle and we fill it with green. We add it to our Pein, and then we set animation equals new timeline, new keyframe duration dot milliseconds 50. So that's the initial time between frames in this animation, and this is the handler that's going to be executed between each time slice, and it's going to execute our move ball method. So it's not like we have a bunch of fixed frames that are going to be presented in sequence, but rather what's going to happen is every time it's time to change frames, we're going to repaint the entire ball scene, and that will effectively move the ball to a new position. The timeline cycle count here is going to be indefinite, which means this is just going to repeat forever and ever. And once we've got everything set up, we start the animation playing with this line here, animation.play. Now the play method in our ball Pein is simply going to do an animation.play. The pause method will do an animation.pause. Next, let's talk about how the speed of the animation is controlled here. Well, you'll notice there's an increase speed method and a decrease speed method. Now you might think that what these things are going to do is change the time in milliseconds between frames. Let's just scroll back up and see where we define that. Notice it was initially defined to be 50 milliseconds. It turns out we're not going to touch that value directly, but rather what we're going to do is change the rate. So that doesn't directly change the duration. The duration is still going to be 50. Well, it won't quite be, because what will happen is the rate is going to be a fraction of that value. So if we were to set the animation rate at 1, it would mean there would be in fact exactly 50 milliseconds between frames. If we set it to 2, this value actually halves, because 2 would mean we want it to go twice as fast, which means the duration would have to drop by a factor of 2. If on the other hand we set it to 0.5, that would mean it would be twice as slow, in which case the duration between frames would effectively be 100 milliseconds. So it's a little bit tricky and maybe not completely obvious here. But get rate is initially going to be 1, and if we increase the speed, we bump it up by 0.1, so it becomes 1.1. And if we continue to increase it, it becomes 1.2, 1.3, 1.4, and so on. If on the other hand we try to decrease it, then it's going to go down by 0.1. So it can go all the way to 0. It won't go negative because we do have a check and balance here. If the animation rate is greater than 0, then we'll allow it to go down by 0.1. Otherwise, we'll just leave it at 0. So we can't go negative, but we can go as far as 0. On the other hand, we don't apparently have any checks or balances on how fast we can make it go. So this could get larger and larger and larger because we haven't put any constraints on it. So that then determines what the speed of our animation is going to be. And we also have a method that returns the rate property here. So let's look at the bottom of this, where we actually determine how we're going to move the ball. So if the x-coordinate is less than the radius, or the x-coordinate is greater than the width of the stage, or the Pein actually, minus the radius, then we know we can decrease x by, or change, that means we have to change the direction that x is heading actually. So remember, dx starts off as positive 1, and when we do a times equals minus 1, we effectively simply change the sign of dx. So what dx is going to do is it'll alternate between positive 1 and negative 1 rather. So every time this if statement is true, we will change the sign of dx, which changes the direction in which the ball moves. We do a similar check on y, but this time we're using the height of the window rather than the width of the window to determine whether or not we were about to bounce off one of the top or bottom sides of the window, in which case we will change the sign of dy again. So after adjusting the signs of dx and dy, we then change the x values by that amount. So even though we're doing a plus equals in both cases here and here, the actual change to x could still be negative because dx might be negative or dy might be negative. After making these adjustments, we change the center of our circle, and that effectively moves the ball from place to place. So let's go ahead then and run this demo and see what it looks like, and I'll tell you what I'm doing in terms of keystrokes and mouse presses so that we can see the pause and play and the speed up and the slow down. So here we go. We're about to run the demo. There it is. Now if I click the mouse, it stops the animation. If I release the mouse key, it continues on its way. Now let's fool around with the up and down arrows. So if I push the up arrow a couple of times, you can see that the ball begins to animate more and more quickly. Now if I push the down arrow, it will slow down. It'll go all the way to 0, but it won't go negative. And it looks like we've hit 0 at this point. It's interesting that it jumped there. I don't have a good explanation for that, but now interestingly, when I push the up arrow, it jumps back to where it came from. I'm going to push the down arrow a few times. Once, twice, again, again. Nothing interesting's happening. And now I'll push the up arrow some more. And there it goes again with a little jump. So I'm not sure what that little bug is about. But in any case, the demo seems to do mostly what it's supposed to do. Now, just out of curiosity, let's see what happens if we change that constraint in our ball peen to allow the rate to become negative. There's a number of ways I could do this, but I'm going to cheat here and just say I'll let it go all the way down to -1. So as long as it's greater than -1, I'll let it go down. This will allow it to be negative just by changing that 0 to a -1. It's probably the quickest and dirtiest way to test this out. So let's go ahead and try the demo that way. So I'll push the up arrow a couple of times, speed it up, and now let's slow it down. I'm going to be careful about this because I don't want to hit negative prematurely. I want to have a good idea about what's happening here, so I'll slowly bring it down to 0. It's still moving, so let's hit it one more time. It seems to have stopped, so I guess it's 0. If I hit it again, it's going to go negative. Well, that's kind of interesting. I think what actually happened there is it started to speed up instead of slow down. And then I think at some point it got negative enough that this was false and it wound up setting it back to 0. So anyway, that was sort of interesting to try that out and see what happened. Well, that then concludes chapter 15.